Welcome Algebra 2 students to the last podcast that we're going to do for Chapter 9. This is the last section in the chapter, so we will basically be taking everything we've learned up to this point and using them to look at equations. So first we talked about rational expressions, how we can multiply and divide them. Then we moved on to addition, subtraction, which was a little bit harder and had more steps involved. We also talked about complex fractions, but for the sake of this section, we aren't going to really worry about that. But the other operations are definitely important when it comes to solving equations that have rational components to them. So hopefully, with the review that you got on Monday and Tuesday in class, this will help you with doing better in this section. So now that you have a better understanding of how we can work with rational expressions and perform different operations on them, it's time to move up to equations. So with an equation, you could have several components to the equation, and as long as one of them is a rational expression, we need to use different methods for solving that type of equation. Now there are a few methods to do this. The first one is to find the least common denominator, and once you've manipulated the different parts so that each one has the LCD, then you can just set the numerators equal to each other. However, this type of method is a little bit harder to follow, and we definitely have an easier way of looking at this type of equation, so we aren't going to consider this when we're solving our equations. The second method is just multiplying the entire equation, so both sides, by each denominator that you see in the equation. This is a little bit easier to deal with, especially because once you multiply everything through by each denominator, you will no longer have rational expressions. You will just be dealing with simple expressions, and we can use the methods we've used previously to solve those equations. And we'll go through some examples so you can see what I mean by that. And the last method is to cross-multiply. And this method cannot be used in all cases, so we'll go through an example so you can see when it's appropriate to use cross-multiplication, especially since this can be confusing if you aren't told when an appropriate situation is. So we'll go through both of these methods with some examples. But before we move on, there are a couple things that we want to keep in mind. Like I said, we're going to be manipulating our equations by multiplying both sides by the same thing. And that thing that we're multiplying it by is going to be the combination of all our denominators. So in the end, we're actually going to be solving basic equations that we've looked at before. And they're usually going to be either linear equations or quadratic equations. So for linear equations, we know that we just want to get the variable by itself. And quadratic equations, we want to get everything on one side so that it's equal to 0, and then we can use some other methods like factoring or completing the square to then solve the equation. So we'll review some examples that require both of these cases. Another thing that we need to think about is that with rational expressions, we said before that your denominator cannot be 0. So with solutions for equations, sometimes we will get an answer that makes our original denominator 0. We call these extraneous solutions. So whenever we solve for these types of equations, we want to plug those solutions back in and see if we run into any problems. Alright, so let's get into our first example. And this one's going to be using our second method, which was just multiplying everything by all the denominators we see. So in this example we have 3 over x plus 1 over 4 equals 10 over x. And in this case we have two denominators, one of them is x and one of them is 4. Our third denominator still has x in it, so we would say that we're going to multiply everything by 4x. Now when we do this, this 4x gets distributed to every single term in our equation. So we're going to have 4x times 3 over x plus 4x times 1 over 4, and that's going to be equal to 4x times 10 over x. So once that 4x has been distributed, we can see quite clearly that things are going to cancel. So in our first expression, it looks like our x's are going to cancel. So we're left with 4 times 3, which is 12. Then in our second expression, the 4's are going to cancel this time, and we're left with plus x. And then on the other side of the equal sign, again, our x's are going to cancel, and we're left with 4 times 10, which is 40. Now it's clear to see that we have a linear solution, or we have a linear equation, and so we're going to get one solution from this equation. And in order to solve for x, we just have to subtract 12 from both sides, and then we get x equals 40 minus 12, which is 28. Remember from the last slide we said that we want to check for those extraneous solutions. Well, since the only denominator that could be 0 was x, and since our solution is not x equals 0, then this is going to be okay. It's not extraneous, and our final solution is x equals 28. Moving on to our next example, things get a little bit more complicated here. So we can see in our second expression that the denominator has not been factored, and that's what we're going to have to do first. So rewriting this equation, we have 3x minus 2 over x plus 1 plus 5 over, and this needs to factor into two binomial terms, both starting with x, and it looks like we'll have plus 1 plus 2. Now to figure out how that works, we just need to make our t-chart, and we need things that multiply to 2 and add to 3. The only factors of 2 are 1 and 2, and sure enough, those add to 3. So we're good there. So that's why we get the x plus 1 and the x plus 2. And then on the right side of our equation, we leave it as just 5. In the other examples that we did in previous sections, we changed it so that our regular expressions were rational expressions by putting the expression over 1. In this case, we don't have to do that because we're only multiplying here. We're getting rid of our denominators in this process, so we don't really have to consider multiplying everything by 1. That's kind of an extra step that's unnecessary. So instead, we're going to multiply everything by our more complicated denominators. In this case, we're looking at x plus 1 times x plus 2. Now we don't need to include the x plus 1 from the second denominator for a similar reason that we looked at before. When we were considering the LCD of our denominators, we did not include parts of the denominators that showed up throughout. So since x plus 1 is in both denominators, we only need it once when we're multiplying everything through. Now when this happens, we have to consider the effect of this multiplication on each term. So we're going to multiply x plus 1 times x plus 2 by our first term, so 3x minus 2 over x plus 1. And we're also going to multiply it by the second term, which is 5 over x plus 1 times x plus 2. Now we'll get to the right side of our equation in a second. First, let's go ahead and simplify this left side. The right side is very straightforward, so we'll get to that in a second. When we do the multiplication in the first term, the x plus 1's are going to be able to cancel, and we're left with x plus 2 times 3x minus 2. Similarly, with the second expression, we can actually get rid of everything in our denominators and all of the complicated factors because they're in both the numerator and the denominator. So we're left with just plus 5. Now we can look at our right side and see that it's going to be 5 times x plus 1 times x plus 2. This might be a good place to stop the video, look at how we got to this point and see if you have any questions. If you do, see if you can work through them. Otherwise, write them down and we'll talk about it in class. But moving on, we can see that on both sides we're going to have to FOIL things out. So contrasting this to what we'd done in the other sections, we wanted to leave things in factored form back then. Now we want to get things into the simplified form that we're used to. So we want to get x squared terms and x terms and constant terms. In order to do that, we need to FOIL and distribute. So on the left side, we have to FOIL out our first part. So that's going to be 3x squared, just the x times the 3x. The outside terms would give you minus 2x, inside would be plus 6x, and then the last terms give us minus 4. We're still adding 5 from our second part, and then on the right side, we're going to have the distribution of the 5 happen last, and instead we're going to FOIL our two binomial terms to get x squared from the first terms plus 2x plus x plus 2 from the last. So this is just a review of the method of FOIL that we've used previously. If you need help with that, just go back to review your notes on how to FOIL. And then we can go ahead and combine our like terms on each side. We know that in the end we want to solve this equation for 0, but we don't want to do that until everything is as condensed as possible on each side. So on the left side, we can combine our x terms and our constant terms, which gives us 3x squared plus 4x plus 1. And then on the right side, we're going to combine our x terms, but we're also going to distribute the 5. So let's say that this is going to be 3x. So we'll get 5x squared plus 15x plus 10. So the 5 gets multiplied by the x squared, the 3x, and the 2. When we move things to one side or another, we do this based on what's going to give us the bigger x squared term, so the more positive x squared term. So it looks like we want to move everything to the right because 5x squared is bigger than 3x squared. So when we do that, we're going to have 0 on the left, and then we're going to subtract 3x squared from 5x squared, which gives us 2x squared. The 15x minus 4x gives us plus 11x, and then the 10 minus the 1 gives us plus 9. Now we're going to have to factor this out, or at least see if it can be factored. If it can't, we can rely on other methods that we've seen before, but it's always a good idea to see if we can factor this. So when we have an a value that's bigger than 1, we need to multiply that value by our last term. So 2 times 9 gives us 18. So it needs to multiply to 18 and add to 11. So 1 times 18 isn't going to cut it. That would give us 19. But 2 times 9 does add to 11. So it looks like when we factor this, we're going to have a 2x and a regular x in our binomial terms. It's going to be addition for both. In order to get the 2, we want to have x plus 1 so that our outside terms can multiply to 2x. And to get the 9x, we just have a 9 here. So that's how we factor our right side. And then, since it's equal to 0, we can set each part of our product on the right side equal to 0. So that would give us 0 equals 2x plus 9, and 0 equals x plus 1. And then we can solve each of these equations for x, and those are going to be our possible solutions. So with our left equation, we would get negative 2x equals 9 if we move 2x over. And then that gives us x equals negative 9 halves. And then from our right equation, we just move the negative 1 over, so that would give us x equals negative 1. So those are our possible solutions, but remember we said that that's not necessarily going to be true for both of them, that both of them are going to be real solutions. And we can test this by plugging each one in. So it looks like we only get issues when this denominator is 0, so if x were negative 1, and if x were negative 2. So the negative 9/2 is not an issue. That's going to be a final solution. But this x minus 1, x equals negative 1, is not going to cut it because that would make both of our denominators 0. So that is not going to be a solution. That would be considered an extraneous solution, and therefore the only solution to this example is x equals negative 9/2. The last example is dealing with cross multiplying. So you're probably wondering, when can we cross multiply? And the answer to that question is when we have an equation where both sides are singular rational expressions. So there's no addition of expressions, there's no subtraction, you just have one rational expression on the left equal to one rational expression on the right. That's the only time that we can cross multiply. So cross multiplication means that you are multiplying the numerator on your left by the denominator on your right, and then you're multiplying the denominator on your left by the numerator on your right, and you're setting those two products equal to each other. So let's look at what this means. If we do our first product, that would give us x from our numerator on the left by the denominator on the right, which is x minus 1. We want to put that in parentheses because we need to distribute this x to both parts. And then on our right side, we're going to have the numerator of our right side multiplied by the denominator of our left side. It doesn't matter which order you do that in. In this case, it's easier to put the 3 first because, like we talked about in class, we want those simpler terms out front. And that's about it. Now we've set it up so that we can distribute on both sides and then see if we have a linear or a quadratic equation, and that will tell us how to solve it from there. So distributing on the left, we get x squared minus x, and on the right we have 3x plus 12. So because of this, we can see that the x squared term means that we have a quadratic equation, so therefore we're going to move everything over to the left side where the x squared term is, and then that will be equal to 0 on the right. So when we do that, we have x squared minus x minus 3x minus 12 equals 0. Now in that step you could have combined the x terms together, but we'll just do that right here. So x squared minus 4x minus 12 equals 0. And then we want to see if that can be factored. So we would have to multiply to negative 12 and add to negative 4. So 1 and 12 is not going to work, no matter which one's negative. 2 and 6 could work, and in order to get a negative 4, it looks like we would need 6 to be negative, because 2 minus 6 is negative 4. So that's going to be our correct factorization. So that'll be x plus 2 times x minus 6 equals 0. Again, we have two factors set equal to 0, so we can change this into two equations. We'll have x plus 2 equals 0 and x minus 6 equals 0. So solving for x in both cases, we get x equals negative 2 and x equals 6. And again, our last step is to check to see if we have extraneous solutions. The only problems we would run into is if x were negative 4 or if x were positive 1, and since neither of these were the solutions we got, then neither of them are extraneous and both of them are real solutions of our equation. So that's about it for 9.6. You'll get to see more examples in class on the EL days so that we can work through those, and we'll also do a little bit of review to get you ready for an upcoming quiz. So the first task that I want you to complete before EL days is to do the homework assignment that was given in class for 9.5. This could have been the adding and subtracting rational expressions, or it could be the homework from complex fractions. Try to get those done before we start covering new material, so covering this 9.6 material in class, because then it'll be right after you've learned about it and it'll stick in your head easier. Then the next step is something you've kind of already done. Watch this podcast. Again, we talked about strategies in class for using this podcast, which would be to rewatch it, stop it, rewind it, fast forward it, go through the examples on paper if you're more of a visual person or somebody who likes to work through things. And also, you are encouraged to take notes. It's not required, but some of you are having issues with remembering what the video was about or remembering how to go through things and how to refer to the examples. So if you have notes on that, you can bring those to class and everything will go a lot smoother with our review. And then, of course, as always, write down a question or two that you have about this podcast. It could relate to concepts or examples, or it could be information on previous podcasts. So try looking at those other videos, because we are going to have an upcoming quiz that you're going to want to start studying for. And the quiz is going to be on things from Chapter 9, but we will give more details on what that quiz is going to cover exactly in class. So go through these tasks and get ready for our review in class for the EL days.